Day 6 of 90 focused on functions. Today I wanted one thing to feel clear: making functions feel like concrete data modeling and control flow, not syntax trivia. The goal was not to memorize a stack of tools. The goal was to pin down the service rule first, because once that boundary is visible, the implementation starts looking like a coherent flow instead of a scramble of conditionals. The first checkpoint was make values, structs, and interfaces say one clear thing about the state they represent. That matters because a good solution should let me explain why the next move is legal, not just show that the code happened to pass one sample input. If that rule is visible, I can rebuild the solution even if the example changes. The second checkpoint was use control flow and method choices to make valid transitions obvious. That is the part that turns the topic from an abstract label into something operational. I can read the input, decide what state deserves to survive, and ignore the noise that will not help the next decision. The implementation shape only earned trust once I kept returning to the last rule: prefer small explicit data shapes over clever abstractions that hide the real meaning. That is where the code stops being decorative. Every update either protects the service boundary or it does not, and that makes the debugging path much cleaner. The common breakdowns were predictable. The first one was using broad or vague types until the data model stops explaining itself. The second was writing control flow that technically works but hides which states are actually valid. Those mistakes look different on the surface, but both come from letting the state drift away from its original meaning. I also wanted a compact practice plan, not a vague note to build more services later. My rule was to state the service rule, trace one request path, and then confirm that each dependency still tells the same story. That kind of drill is small enough to repeat but strong enough to expose weak reasoning quickly. What helped most is that functions now feels like a repeatable engineering decision. If the load pattern changes or another service gets involved, I still know what question to ask first. That is the signal I wanted from today's work, because it means the lesson is portable instead of tied to one toy example. So my recap for day 6 is simple: making functions feel like concrete data modeling and control flow, not syntax trivia. The useful anchors were make values, structs, and interfaces say one clear thing about the state they represent, use control flow and method choices to make valid transitions obvious, and prefer small explicit data shapes over clever abstractions that hide the real meaning. When those are visible, the code is easier to test, easier to explain, and much easier to repair after the first wrong attempt. One more reason I wanted this locked in is that harder production scenarios usually change the surface details, not the core service rule. If that rule still survives, I can adapt the implementation instead of restarting from zero. That is also why I care about ownership so much in Go. Once the package boundary is honest, the rest of the code has a much better chance of staying boring in the good way. A lot of debugging time disappears when the request path or data path is obvious from the structure. The language helps, but only if the design is pulling in the same direction. So the real test for me is simple: could I explain this same design tomorrow with a different example and still keep the same rule intact? If yes, the lesson probably landed. I also like asking where the first confused teammate would get stuck. That question usually points straight at the place where the boundary is still implied instead of written down. When the code is shaped well, the packages, functions, and error paths tell the same story. When they do not, the mismatch shows up in review long before it shows up in production. That is why I keep practicing these topics with one concrete path at a time. The small path is enough to reveal whether the core rule is real or whether I only recognize the terminology.